The next session what we will be doing is intermediate modifying and terminating devices. This is an extension of module 4. Let us recall what is the principle of generalized measurement system. So in the generalized measurement systems there are three parts. The first part is a detector part, so we will call it as primary stage, and the last part is nothing but it is a terminating devices. Terminating devices is nothing but it can be an ending stage. So primary stage and ending stage. During the conversion of one parameter into another parameter, that means say for example I want to convert a load cell, the number of components in kg, to a voltage signal as a display unit. Say for example, for that conversion, I need some modification in between final stage and primary stage. So final stage is terminating stage and primary stage is detector stage, or primary transducers or secondary transducer will be used in first stage, primary stage. Between those two things, I need to amplify the signal or attenuate the signal or filter the signal, or sometimes I need to add the signal, sometimes I need to subtract the signal, sometimes multiplexing, deep multiplexing. These things will be coming under intermediate modifying devices. Basically what I am doing is the input from the detector is modified according to the final stage or terminating device like display. In the load cell, I need to display number of kgs, or in other words, I need to display the components in terms of kgs. Say for example, 58.8 kg. So I want to display 58. How to display 58? I need to do some intermediate modifying devices. I need to modify the circuit to get LED display 58.8. Let us take an example of Bourdon tube pressure gauge. In the pressure gauge, the first step is I need to sense the pressure. The pressure is sensed by the help of any transducers. You can use primary transducer or you can use secondary transducer. So here the pressure will be converted into displacement. After that, I need to show what is the displacement here. The displacement is the parameter where I need to modify it. The displacement is modified according to the deflection of a scale or pointer. So when it is 20 kg per centimeter square, the pointer will be showing 20 kg per centimeter square. How it is showing 20 kg per centimeter square means in intermediate modifying devices, the displacement is being amplified, because of which you are getting the output display as 20 kg per centimeter square, and the movement of pointer should be specific due to the variation of displacement. In other words, as the displacement varies, the pointer should also varies in proportion to the displacement. So the relationship between displacement and pointer should be linear. Being the linear displacement, we need to get more amplification. That means I need to capable of showing the displacement in terms of pressure. Say for example, if there is a small variation, 0.1 mm of displacement, that corresponding factor should show 10 kg or 20 kg like that. That means some amplification will be there in between displacement and the pointer. So this is what we will be doing in intermediate modifying devices. In intermediate modifying devices, there are several elements. We can do mechanical, using a mechanical linkages, mechanical intermediate modifying devices. Even we can do electrical intermediate modifying devices. We will be varying voltage and current. Also electronic intermediate modifying devices. Electronic intermediate modifying devices are the circuits, chopper amplifiers, etc. And again there is a CRT, output display. Output display is also monitored, and we can see what is the waveform. Based on the waveform, we can check how the system behaves. So basically CRO is all terminating devices. So here we will be seeing what is intermediate modifying devices in detail along with terminating devices like display segments. Let us take what is an intermediate modifying devices. Already I said in intermediate modifying devices, the primary signal which is sensed from the transducer is amplified or attained or modified, or sometimes it is added or subtracted, multiplied or divided, etc. These things will be done in intermediate modifying devices, and we are modifying the sensed signal from the detector according to the output. If the output is analog, we will be monitoring analog signal. We will be modifying a signal into a analog signal. If it is a digital, there might be possible of conversion of analog signal to digital. If the signal sensed in the detector is analog and signal what we need in the output is a digital, what we will do is in intermediate modifying devices, there will be a conversion of analog signal to the digital signal along with some amplification or attenuation will be there. Let us see mechanical intermediate devices. Mechanical intermediate devices you can see in comparators, pointer and scale, etc. Those things are mechanical intermediate modifying devices. Whenever the display is a mechanical quantity, so analog signal like pressure, like force, those things will be modified based on linkages, or sometimes we will be using gears, etc. Those things will be used in between final terminating device and primary input device. So there are some problems in mechanical systems. In the exam they can ask, explain mechanical intermediate modifying devices problems. So these are the inherent problems. So there are about 8 problems, you have to elaborate it. That will be asked for 8 to 12 marks. Based on the marks you elaborate it. Let us see the first inherent problem in the mechanical system is kinematic linearity. What is linearity? The output and input relationship must be linear. Why it is linear? As I already told, the displacement which is sensed in the primary stage is to be amplified. How it is to be amplified? The scale must be amplified. For 0.1 mm of displacement, it should show the converted reading correctly. Otherwise, what happens? It leads to wrong display of result. Suppose for 0.1 it is showing 10 kg per centimeter square, for 0.2 20, 0.3 30. So the relationship between the displacement sensed in the detector and the pointer in the output, these two must be linear in nature. Suppose what happens? We are using many linkages. Kinematic is nothing but we will be using kinematic linkages. Because of kinematic linkages, there will be a friction. Because of that, what happens? The deformation will be taking place. Because of the deformation, what happens? The value what we are obtaining the display, there will be a deflection in the pointer, 1 to 2, 2 to 3. This will happen at the many stages. Take an example of filling of air in your two-wheeler. If you use an analog meter, what happens? There will be a deflection, 20 to 30. There will be a long deflection. So this long deflection should not be there. Because of that long deflection, you cannot know what exactly the value will be. So this long deflection, that means more deflection will be there because of deformation in the linkages. So this need to be avoided. Also sometimes tolerance is not being controlled. The pointer from the deflection and the pointer from the primary devices. So these two pointers, in between there is some devices for the amplification. During that, what happens? Suppose a gear is being used in between those two linkages in order to have a flexibility. If the gear is not mounted properly with the linkages, or with the pins. What happens? Again there is a deformation. Because of this deformation, again the error will be generated. Because of that wrong reading you will be interpreting. So that is one of the desired in kinematic linearity. The second thing is mechanical amplification or gain. Usually we will be using mechanical advantage. Mechanical advantage is nothing but it is the load by effort. Here the load by effort is expressed in terms of displacement, that is output displacement versus input displacement. It is a ratio of output to input, anything. It can be a displacement, it can be a velocity, or it can be an acceleration. So basically the displacement, output displacement by input displacement will be mechanical amplification or gain. So wherever there is a gain will be there in intermediate modifying devices. What happens sometimes, these two displacements are not intact because of errors. What are the different types of errors? There are systematic errors, there are random errors. Systematic errors means the error because of some material, error because of linkages. What are the errors of linkages? One is the linkages will have some weight. Because of that weight there will be inertia. That inertia will be affecting during the movement of the pointers or movement of the linkages. Also elastic deformation, the property of the material. What type of linkages are used? That material type having a desired properties. What are the properties of materials? In that there will be a deformation. The deformation can be elastic or plastic. Most of the cases, since we are used in intermediate devices, the deformation takes place will be elastic in nature. Elastic in nature. Then random errors. Random errors are nothing but friction and backlash. Friction, there will be a friction between two linkages. If you connect two linkages, there might be a friction. You connect a link with the gear, again there will be a backlash. If there are number of gears are mounted, the movement of gears, sometimes it will be lost. The relative motion between the gear will be lost sometimes for some span of time. Because of that the pointer cannot move. At next stage it will show some reading. Even though it will show some reading, that's why calibration is required. So these two errors will be there as a linkages, as a mechanical system. Whenever there is a mechanical system, you cannot eliminate friction and backlash. That will be there. So this is about gain or mechanical amplification. You need to explain how these errors will be affecting the transformation of the detection from the primary to telemetry or final stage, terminating devices. Sometimes there will be a no reading. The pointer will not move because of friction, because of backlash, because of any systematic error. Sometimes the pointer will move. Sometimes it takes some time to move. So why this happens? Because of error. So these things will be affecting mechanical amplification or gain. The next thing is reflected frictional amplification. Reflected frictional amplification. So basically it is a friction force, the force due to friction. The frictional force are almost static in nature. The frictional force will be taking whenever there is a rest. The frictional force will be there always in all the mechanical linkages. We need to overcome the friction. How to overcome the friction? Lubrication will be there. Lubrication must be provided, greasing, those things will be, maintenance will be frequent. And suppose if we not maintain it, what happens? The frictional force will increases. The frictional force will get amplified. Sometimes gears, what happens? During the ball joint there will be a struck. If you put first gear, yes, it is comfortable. Sometimes it is very smooth. Sometimes it is very rough. If traffic is more, I want to move the car. I cannot put the gear easily because it will be a rough. Why rough? It was correct in the previous stage. Now it is being stuck in a traffic, in a middle environment. How? This is due to friction, and the friction will be get amplifying in subsequent stages. Finally, what happens? The material may get worn out. You need to replace the gear itself because of frictional force amplification or errors amplification. Clutch, frequent clutch will be using in cars. What happens? Plates, if we not using the clutch in a smoother fashion, I will be using in a rough fashion, half clutch like that. What happens in the stages? In the stages, the clutch plate or pressure plate will get vanished. It will not vanish at the first stages. First, the clutch becomes hard. After subsequent stages, the pressure plate will get damaged. You have to replace the entire clutch assembly. Clutch plate is gone. So, at the meanwhile, what happens? At the first stages, the frictional force will be generated. There will be a frictional force. Then it will get amplified. Finally, the component may get failure. So, these things will be happening. So, the expression for this is algebraic sum of frictional forces. A is amplification, and this is summation. The frictional force can be generated at any time, at any linkages, and that will get amplified. So, the same thing, this is an expression where A is gain, F suffix small f is actual frictional force, and F suffix small f4 is total frictional force. That means the smaller frictional force will be added up together, and finally you will get large amount of friction that leads to damage of component or material or any assemblies. So we need to take care of this. Then reflected inertial amplification. Inertia forces are caused due to the movement of the members. During the movements you will get inertia force. Since there is a movement involved in it, it is a dynamic force. Wherever there is a dynamic force, there is an inertia force. Wherever there is a static, there will be a frictional force. According to Newton's second law of motion, the force is directly proportional to rate of change of momentum. So F is directly proportional to acceleration. Inertia force directly depends upon the acceleration. As the acceleration increases, inertia force increases. And there is no reason to set up inertia force. Dynamic forces can be set up at any time, anywhere. We cannot predict that very easily. Always there will be a dynamic forces, always there will be inertia forces, and it cannot be fixed completely. So inertia forces will be there in the vehicle, but it can be reduced by proper balancing of reciprocating or rotating masses. What happens? Inertia force will be developed. This is an inertia force. Again, it will get summed up and you will get total forces. And generally, the total force will be calculated with the help of frictional force plus inertia force. In other words, static force plus dynamic force. That is a force will be acting on the system. And almost these forces will be there. It cannot be eliminated. These forces will cause vibrations which is undesirable. And how to fix it? You can reduce it, but you cannot eliminate it. Always there will be a vehicle sound. You cannot completely eliminate vehicle sounds. If you want to completely eliminate vehicle sound, you need to eliminate all the components. Because in all the components, there will be a forces. Either it might be static forces during movement, it will be a dynamic force or inertia forces. We cannot eliminate. Sometimes friction is advantage, sometimes friction is disadvantage. Here also sometimes inertia is advantage, sometimes inertia is disadvantage. Most of the cases inertia forces will be developed and it can be magnified. Then amplification of backlash. Backlash is the error which is generated in the gears, because of which the relative motion between the gears will be lost. The teeth will be meshed, one teeth will be meshed with other teeth, that will be causing a relative motion. If there is a backlash, the relative motion will be lost for some times. And because of which what happens? again vibration will be set up. Because of vibration, wear and tear of components will be taking place. Backlash will be mainly generated due to non-constraint in linkages. The linkages must be constrained. It should not oscillate, it should not vibrate, it should not vibrate freely. Whenever you start the movement, if the link is moving freely, then there will be a vibration. Because of that link, if that link may touch on that part, what happens? There will be a backlash. The relative motion of the gears will be stopped. And this non-constrained linkages will be because of fits. That fit is, there are several fits: clearance fit, interference fit, and transition fit. And you know how to select those fits depending upon the requirement. If there is a no force, clearance fit. If there is a force, it is an interference fit. Sometimes we need both the things. In that cases, you will be using transition fit, where pressure is also involved, force is also involved. Pressure or force same will be involved. Also, it will go as usual. And during the selection of fit also, the tolerance what you will be give, that matters. If improper selection of fit leads to non-meshing of gears, because of that what happens, it may have less angle of contact between the two gear teeth. Because of less angle of gear teeth, there might be loss in relative motion. Instead of 1 RPM, it may go slow, or it may go fast, or it may cannot rotate. That means the relative motion will be affected, because of which the backlash will be generated. Again, in all the gears there will be a backlash. Either in one teeth or two teeth there will be a less proper of contact, because we need to satisfy the condition module. Because of that there will be error, and this error should be eliminated. We cannot completely eliminate, we need to reduce, because it will get amplified to get total backlash. And this backlash is measured in terms of displacement. So YB is actual displacement due to backlash, YBP is total displacement due to backlash error, and A is amplification. Again, in all the cases there will be amplification or gain. This is an equation to fix the backlash. Calculate how much backlash will be generated. Then amplification of elastic deformation. All the materials, there are different materials will be used. Different materials will have different properties. Different properties will be having different elastic constant values. So because of that, elastic deformation will be varied. Basically, there will be a springs. Almost in mechanical system, there will be a number of springs will be used depending upon the weight and suspension types, etc., etc., flexibility. Spring parts will be causing elastic deformation, Young's modulus, and deflections will be there. Because of the deflection, you will get some type of comfort in case of shock absorber. In some cases, larger displacement will lead to certain amplification of other elements. So we need to avoid this also. Elastic deformation, because of material properties, the material will tend to fail at some day or some time. How it fails, that is measured using elastic constants. Sometimes the value of spring stiffness is also taken into considerations. After long usages, what happens? The spring becomes more elastic in nature. That means the deformation of the spring will be slightly more. And we need to identify that case, and we need to replace the spring. Otherwise, what happens? Enormous amount of amplification will be obtained. This may cause damage to other wear elements. So we need to concentrate on what is the elastic deformation caused due to the spring. Same thing, it is also measured in terms of displacement. Delta YE is change in deformation. We will be measuring the distance in deformation. That means change in length by original, like that. Final length minus initial length. And then displacement, total displacement. This is actual displacement, and this is total displacement due to elastic deformation. Then next, tolerance problem. In the metrology and measurements, if there is any tolerance problem, then the screw or fit you cannot obtain easily. Suppose you take an example of assembly of M20 nut with M20 bolt. If I take M20 nut in India, If I take M20 bolt in Japan, you assemble it, it will get assembled because there will be a convention. The convention, standardization, they will be following. This process is nothing but interchangeability, interchangeable of parts. M20, if I take M20 means there is some standard. Also there is a standard for fits. If fit is not having sufficient amount of tolerance, then what happens? We need to change the component itself. You take an example of journal bearing, journal rotating in a bearing. Journal bearing, journal rotating in a bearing. If you give sufficient amount of clearance, then it will easily rotate. If you give more clearance, it may get oscillate. If you give less clearance, it will rotate. If you give zero clearance, it will not rotate. So, very important thing is clearance, fit or tolerances. Here we are giving clearance fit for journal bearing, and sometimes what happens, whenever you apply load, the axis should not be changed. That is also the case. Sometimes journal bearing will be designed in such a way that it can have clearance fit, or sometimes it may have a transition fits. Most of the cases journal bearing will be having clearance fit, and whenever you give more tolerance, the motion will be lost, the movement will be lost. There will be offset error, because of that the movement will be lost. The tolerance problem you have to consider, we have to take into consideration proper design of fits must be employed, and proper design of tolerance must be given for the several types of fit based on the applications. That is very important. Sometimes I don't want push fit, sometimes I want only a clearance fit. In such cases, the component will be designed in transition fit is not required. Directly you can give clearance fit itself. So these problems you have to take into considerations. Next is temperature problems. Very desired. This temperature problems will be there always. Whenever you take the large measuring inspections devices like CMM and all, the environment will be maintained and the atmosphere will be having an air conditioned. It is an AC environment where the temperature is maintained. If some temperature is increased or decreased, then contraction and expansion will be happening. Even in the design of railway track also, they will give some gap between steel rails, the cast iron rails. Why? Because the steel have a property. If the temperature increases, it will get expanded. If the temperature is less, it will get contracted. Because of this contraction and expansion, what happens? It leads to change in the linear dimension, because of which the dimension may vary. All the instruments will get heated up. We need to take care what is the temperature of the instrument. Even vehicle, after 3 hours we will give some 10 minutes of break, because at the higher temperatures there might be more damages occurs inside the components. That's why we will give some break. After that, the lubrication will be flowing, that will be taken care. And maintaining temperature is also one of the criteria which is not possible in almost all the cases. The temperature will be changing almost at every instant of time, and we need to monitor that. There are two problems in temperatures. One is zero shift, another one is scale error. Zero shift is nothing but it is a contraction and expansion, as I already explained in the steel railway track. Because of this, what happens? The linear dimension will change. This is the dimension at temperature T1. L0 is the dimension at temperature T0. What is the change of dimension? So L1 minus L0 is the change of dimension. That results in change in temperature, and again it is corresponding to how much it is changed. It is coefficient of thermal expansion. And again, this is a material property. Coefficient of thermal expansion is different for different materials. Then next is scale error. Scale calibration is very important in almost all the cases. Because of this, what happens? Scale error, the pointer may not move, or the temperature scale may get affected. Like this, there are several things, and this is scale calibration must be done frequently, and scale error depends upon the material depends upon the elastic properties like Young's modulus, and this is the equation E1 is equal to E0 into 1 plus C into delta T. Scale error is measured in terms of modulus of elasticity, and zero shift is measured in terms of linear dimension or any dimension. Next is lot of disadvantages in case of mechanical systems, but most of the cases when it comes to the cost, it is economical, and these errors will be there always, but we need to avoid the amplification of errors. That's why the name reflected frictional amplification, reflected inertial amplification. That means we will be calculating what is the total inertia force, what is the total frictional force, what is the total backlash, what is the total zero shift, what is the total scale calibration. These things value we will be calculating, because of which what happens, we will be knowing how exactly the error will be generating. We need to avoid these errors, we need to reduce these errors, and most of the cases inertia and friction we cannot eliminate in mechanical system, that will be there always, but we need to minimize it. To overcome the limitations, what we have done is we are using electrical intermediate modifying devices. That means instead of linkages and gear arrangement, electrical circuits will be used. What are those? What are the advantages of electrical methods? Number one, there is no friction and inertia in electrical systems. Friction and inertia will be completely eliminated. Next, voltage amplification of larger order. That means here the magnification is limited in case of mechanical systems. If you want more magnification, you use more links. If you want 100 magnification, you use 100 links, like that. You want more larger the amplification, linkages used must be larger, number of components will be larger. But here voltage amplification can be done in the highest way by varying the resistance. That is one of the advantage in electrical, and also that leads to proper maintain of power. Power amplification is also done. For power amplification, the best thing is hydraulics and pneumatics. Hydraulics, high force application, pneumatic, high speed applications. So these are the flexibility of electrical methods in intermediate modifying devices. Let us see what are electrical intermediate modifying devices. In electrical, basically we are varying voltage or current. Modification is based on voltage or current or power. So V is equal to IR, you have to remember, we will be amplifying the voltage. Sometimes it may require filtering. Filtering means the sound, what you are playing, the signal is pulsating. We want a stable signal. For that we will be using capacitor. Because of that you will be getting filtered signal. Even in case of cell phones also the same problem will be there. Next, integration of signal, you can add any signal. Differentiation, you can remove the signal. So these will be obtained using operational amplifiers. It is one of the circuit used in electrical intermediate modifying devices. Let us see what is the input circuitry. Whenever you use electrical intermediate modifying device, there will be a circuitry, there will be a modification of a circuit is essential. So input circuitry we will be calling. It consists of a power supply, voltage or current or resistance, like that. You can have number of resistance, you can have number of capacitance depending upon the circuit. There are several input circuitry. One is current sensitive circuitry. That means here the current is the parameter. Whenever the output changes, the current will also changes. Next, Backlash circuit. Backlash circuit is voltage sensitive circuit. So small variation of output, the voltage will be changing. Next, voltage dividing circuit. Sometimes I want more voltage to be for display unit. In that cases, I can divide the voltage. I can have two voltages for input separate and output separate. This we can have. Then voltage balancing circuit. Sometimes I will need to balance the voltages. So I can use any network like Wheatstone like that, and we can balance the voltages. Then bridge circuit, Wheatstone bridge network. Again, I need to balance the resistance. Then resonant circuits. Sometimes the voltage will be operating beyond the value. In such cases, resonant circuits will be used or peak circuits will be used. Basically, input circuit consists of an active or passive transducer. Active transducer or nothing but self-powered transducer. Example for that is piezoelectric crystal. Piezoelectric crystal voltage is converted to a displacement. Then passive transducer or powered transducer. Whenever you want to have a passive transducer, you need to have a separate power supply for that. Because of that, it will be auxiliary power supply transducer. Because of external power supply, it will be operating. Active transducer, you need not require power supply, but passive transducer, you require a power supply. So these are the basic input circuitry for the electrical intermediate devices. Let us take any of the two things in detail to understand the electrical intermediate modifying devices.